Okay, is everybody ready? Am I ready? I hope so. Good morning. Welcome to the June Argo Workflows and Events Community Meeting. I hope everybody's very excited at the moment that we're all going to be able to get out of our houses and go and get back on with our lives and enjoy a bit of the summer sunshine. I know that I am. We're going to have two demos stroke previews today. One will be from, correct me if I pronounce this incorrectly, from HongKun, who is going to demonstrate a little piece of software he's written called Jupiterflow, which is kind of one of the really interesting bits of software we've discovered inside the Argo workflows ecosystem. And I always really enjoy things that build on top of Argo workflows. I'd love to see what people are doing with it so we can understand the kind of different directions that things like data processing and machine learning are going into. And then I'm going to give a demo of a proof of concept or preview alpha piece of software in Argo Labs called Argo Dataflow that's oriented around data processing, and will probably, I'm hoping, will be quite interesting to anybody using Argo workflows or Argo events. So we're actually you're not going to see very much in the way of Argo workflows and Argo events at the moment. So if you are interested in that, of course, we have some great videos from version 3.0, and 3.1 is just right around the corner as well. So I think that's going to be very exciting. Okay. So, HongKun, are you ready to give your demo?
Yes. Actually, I have a slight presentation and a demo. Okay.
Go for it. I'll stop sharing my screen so you can take over.
Okay, thank you. Can you see my presentation?
Yes.
Okay. Okay, first of all, thank you for having me. I want to share you about Jupiterflow, a better way to scale your ML job. My name is HongKun Yoo, and my targeted audience is as follows. And first of all, please understand my English because English is not my first language. Okay, the target audience is follows. For data science who are not familiar with Kubernetes, but want to use the power of Kubernetes, and for MLOps engineers who want to provide an efficient ML environment, and for analysis, looking for a better ML tool. So I want to introduce an ML tool for data scientists. Today's scope is mainly on model development, especially for training. My name is HongKun Yoo, and I run a blog post named Coffee Whale, mainly on machine learning and Kubernetes. And I work at Line, which is a messenger widely used in Asia, including Japan, Taiwan, and Thailand. And I work as a data platform engineer based on Kubernetes. Before I start, this project is nothing related to my company, and it is totally my personal project, and I do not speak on behalf of my company. Okay, everyone knows that Kubernetes is great, and it's very useful for ML projects. It handles model node management and job scheduling and resource management and monitoring. It's very good, and everyone loves it. So a lot of people use Argo workflow for data pipeline or machine learning pipeline. But I think there is no free lunch. Not everyone is happy with Kubernetes, especially for data science who are not very familiar with software skills. So I come up with two main reasons of these issues. First of all, it is containerization, and second, writing manifest file was little difficult. For more details, what is containerization? Already you know about this, but I want to emphasize that every time I update my machine learning model, I have to rebuild my container image and push again and run the container. It was, I know how to do it, but it was really tiresome. It was every time I have to do it, I think about, is there a better way to do this? And another thing is YAML help, as every time, it's not every time, but I have to write a YAML code for running my ML job. And maybe somebody who is familiar with this might feel easy, but for data scientists, won't be very easy to learn. They need to learn about Kubernetes and very detailed stuffs about it. There is also a unicorn who can actually are good at data science and software engineer, but not everyone is that unicorn. So I want to introduce Jupiterflow, that you can run your ML job right away on Kubernetes. I prepared a live demo, so you can go into this website and do it yourself. I will show you in my computer. Can you see my Jupyter Hub page?
Yep.
Okay. I will share it. I will share it here. So you can log in with your GitHub account. So this is just a regular Jupyter Hub platform. And first, you have to install Jupiterflow. This is not all you need, but this is all the thing that data scientists needs to do it. Oops, what did I done wrong? And then next, just write Jupiterflow run, and then an option, and just say echo hello. This will create a Jupiterflow Argo workflow YAML file. And then if you go right there, the actual Argo workflow YAML file will be created. Here says hello. You can also run a script. Like there is I made a train.py. This is a regular MNIST Keras training file. It's just a simple training script, and you can run it on your Jupyter lab. It's worked well, but in a lot of cases, we want to scale our machine learning job. So we want to run this script on Kubernetes. So how could we do that? We just run Jupiterflow run, and then write Python train.py. And then the actual code will be appear in Jupiterflow. So the actual script will run. And it will connect with volume. It connects with volume. So here's a download file that I want to download an MNIST file. And if you run Jupiterflow, run Python download, the Jupiterflow, the Argo workflow starts, and then after it finish, there will be a MNIST file in my Jupyter lab. And also you can write a more complex DAG workflow. So if you have 3 command hello world again, and this is similar with the Airflow dependency expression. So you run the first job and the second, and the first job and the third. So you run Jupiterflow run, and with F option, workflow.yaml, and then you can run more complex workflows. This is it. So you can run like this kind of more complex stuff. So this is it about Jupiterflow. So I think Jupiterflow is an interface of Kubernetes for data scientists. So data scientists originally need to use Kubernetes directly. But if you use Jupiterflow, this Jupiterflow will translate your machine learning code to Kubernetes Argo workflow YAML file. So I think Jupiterflow is some sort of translator for data scientists. So, this is why I started this project. So I also run machine learning code, and it was a great idea for using Kubernetes because it handles scaling, node management, and scheduling, all kinds of good stuffs. But using directly Kubernetes and Kubeflow was a little bit tiresome for me because every time I change my code, I have to rebuild my image and I have to run my code. So that was a little troublesome. So I wanted a better way to run my model for efficiency. So whenever I write my code on JupyterLab, I want to run right away. So this is why I made Jupiterflow. So to wrap up, this is my personal open source project, and it's early stage in development, and it has bugs and lack of features. But I think there's still no de facto standard ML tool in this field. Maybe Kubernetes, but I think maybe Kubeflow, but I think Kubeflow is slightly difficult for me to run, very lightweight. So I think Jupiterflow has a great strength and opportunity in this area in training machine learning models. So this is the blogs that the source of my presentation. There is a good blog post that they claim the same problem, that data scientists don't care about Kubernetes. And this blog post is my blog post that I introduce my Jupiterflow to solve these issues. So thank you. That'll be all.
That's great stuff. Thank you very much for giving that presentation to us. Does anybody want to ask any questions? This is a great opportunity to ask about this. I certainly have a question.
Okay.
I want to know, is it written in Python, and does it transpile the, does it use a transpiler to convert it into workflow YAML under the hood?
Yes, it's written Python, and it translates it to YAML file, and it throws the YAML file to the Kubernetes using the Kubernetes Python SDK.
Oh, nice, nice.
Actually, I have a architecture. It's really simple, but so there is a Jupyter Hub and there is an Argo, and if you fetch the pod spec in Jupiterflow, we can get the image and the storage volume. So Jupiterflow just do this, just fetch this information and build it to the build the YAML file and throws to the Kubernetes, and the Argo workflow controller runs the rest of it.
Cool.
Okay, thank you.
Okay, I might get you to ask you to drop your slides into the chat so people can review them as well.
Okay.
Cool. Okay. Anybody else have any questions? Cool. Okay, so I'm gonna steal the screen share from you.
Okay.
Before I do that, let's go back to the right slide. There we go. And does that say Argo Dataflow? I can't see what it's sharing. Let's try and I'm going to do that again because I don't trust it. There we go. There we go. The green line has appeared around it. Can you guys see my slides?
Yeah.
Excellent. Thank you, Bala. So today I'm going to talk a bit about a new project we've been working on to help build out a solution for some of our internal needs at the company that we work for, the core team that works for, and the project's called Argo Dataflow. The use cases for Argo Dataflow are typically processing large numbers of data items. So things like click analytics from a website. We're going to be particularly focused on anomaly detection with inside software systems, but also things like fraud detection and operational analytics. So typically the use cases, you have a lot of items of data coming through your system, typically in real time, and you want to do some kind of near real time processing on them rather than batch-based processing, and you're somewhat tolerant to errors. This is what a typical data flow pipeline looks like. So a pipeline is composed of a number of steps, and Argo Dataflow will execute that pipeline. And the steps typically read data from some source and then optionally write it to a sink. This is quite a complicated example, but in this example, there is a container writing data to a NATS streaming subject. That's then read, then it's run through two filters, one that filters out cats and one that filters out dogs, written to another NATS streaming subject. And finally, there's some processing, and the processing on the cats and dogs is different, and that's written to an output topic. That's pretty common. You're reading from a data source and writing to data sink. Optionally, you can write from more than one sources, and you can read from more than one sources, and you can write to more than one sinks. So it allows you to do kind of fork join processing as well on those items of data. The blue icons in this, we don't have quite a name for them, but you can call them a processor. We have a number of processors out of the box. I'll talk about that in a second. Okay, so what are the currently supported sources? So we can have a cron scheduler as a source, which produces an item of data every minute or 2 minutes. A Kafka topic, a NAT streaming subject, which is basically the same as a topic, both of which are durable, or a HTTP endpoint. So you can put a HTTP service in front of a step within your pipeline and consume data from that. And then you can go through, we've got several built-in operations that you can use, filter, map, which I don't think I'll even explain those two for you. I'm sure you can guess what they are. Flatten, expand, which turn out to be popular operations of flattening a large structured data down to key value pairs and expanding key value pairs back up to structured data. Quite popular, often makes it easy to process data. Grouping, so grouping data as it comes in and then emitting single chunks of data that have been grouped together. So those are the main built-in operations. There's also one called cat, which I haven't mentioned here, which is obviously map, but identity. Then there's a couple of more useful ones for users. A Git operation basically checks out code from Git and runs it as the operation. A container just runs a container image that you've specified, maybe that could be called image. And a handler allows you to actually just write your code directly into your pipeline and allows you to code it in the YAML. It'll compile that code for you and run it for you. So there's no need to actually build and publish an image, which I think we all know is a bit of a pain. Oh, and then we sync it to pretty much the same kind of places the sources, so Kafka, NATS, or a HTTP endpoint. Also a log sync. Anybody who's familiar with Argo events will know that there's a sensor called sensor. I don't think I mean sensor. I mean something else. I think it's sensor.
An Argo event.
Sorry, Bar?
In Argo event.
Yes.
It's a sensor.
Yeah, sensor. There's a sensor called log, which allows you just to write those messages out to log, which is intended for debugging. Because obviously one of the challenges in a kind of distributed system with a lot of messages is you need to be able to trace your messages through the system. And then you can scale your processes up by using either HPA. So if you want to scale up and down using CPU or memory, that's one option. Scale them manually, or scale them based on the number of pending messages in the queue. So if you're using Kafka or NAT streaming, we can determine the number of messages pending. We can scale up and down to meet your load automatically. Okay, so you can't really get away from YAML if you're in the cloud native universe. So this is an example of a pipeline specified in YAML. It contains some pretty much conventional metadata, somewhat inherited from Argo workflows, that allows people to describe their pipeline, who owns it, so who's responsible for if it goes wrong. A lot of people have trouble determining if a customer who owns a particular resource within inside Kubernetes. So we have an out-of-the-box annotation for that, and out-of-the-box description as well. And then you can see that this particular specification, this pipeline contains a series of steps, And if you're familiar with workflows YAML, you can see that they're both called cat. And the first one reads from a Kafka topic and then writes to a NATS streaming subject. STAN is a acronym for NATS streaming. So it's NATS backwards. And then a second step called B, which reads from the subject and writes to an app topic. But nobody likes that. So we've written a nascent Python library that you can use to write your Python in a kind of builder format. So this is not the same pipeline, but this contains two steps here, both reading from a cron schedule, passing to a handler, which is a Python function specified actually in the source code here. And if you use kubeflow, you'll probably recognize this kind of way of doing things, of having a pointer to a function. And then a second step, which does kind of the same thing. And this one actually also showcases a retry policy, and I'll come back to that shortly. Okay, so it's Python, so you can use it in a Jupyter notebook. This again is very new. I'm kind of very interested to get people's feedback on how they might want to author their pipelines. This decision has been based on the fact that we know that people don't really like YAML. They want to write things in Python. That came back very strongly in the survey earlier this year. And so here is an example of running that pipeline in a Jupyter notebook. And we also contain some kind of Prometheus metrics out of the box. So each step within your workflow, your Dataflow pipeline will emit messages such as the number of messages going through, the rate which they're going through, the number that are in flight, and the number of replicas. So you can easily monitor your system to make sure that it's processing it. And this is obviously especially useful if your processing pipeline uses downstream systems, such as it has to reach out to another service to get some kind of data. So this will help you understand that. And you can also look at pending messages and other things to see if data is kind of building up in your system, and build very standard Wavefront or Grafana dashboards with very standard alerting on that, so you know when things go wrong. Okay, so before we go find out more, I wanted to just go through how you could try this out. So we have a quick start guide here. Basically a quick start YAML that you can apply into a namespace called Argo Dataflow system, and that'll create the controller whose responsibility will be to execute the pipelines. And by default, we provide basically a namespace scoped install. So that'll just go into a single namespace. It'll only listen to pipelines and steps created in that namespace. And then there's a user interface that comes with it as well. Maybe familiar to some of you. I don't know if you've seen this particular user interface style before. There's basically a new option on the left-hand side above the event flow option for pipelines, and it lists all the pipelines. And I'm just going to go through now and just the pipelines are all provided in a series of examples. So it's quite easy to go through them. And the examples start at 101 for easy examples and go up to 301 for advanced examples, kind of showing you each of the new features. So let's have a look at the examples. So the first one is kind of a hello world example. This just reads from a source and a sink. And actually this is also, most of the examples are also done in a Python format. So you can have a look at the Python that produces this particular pipeline. And this particular one said reads from a cron schedule, cats the output. So it's an identity map operation, then writes it to a log. And this will then be represented in the user interface here, showing the sources it's reading from and the places it's writing to. Now, cron and log are quite useful for experimentation because, of course, Kafka is typically quite heavyweight, and NATS is kind of modularly heavyweighted. So if you're experimenting, these can be quite useful to help you. If you just click on the particular step within the pipeline, you've got a couple of different tabs containing some kind of useful information here. And the first one just contains an overview of the status, telling you how many replicas you're running and last time this particular step was scaled up. It also contains some information for each of the sources and sinks, giving you the total number of messages, the current messages per second, transactions per second, and in an example of the recent message, you can kind of see what's going through a particular step. And the same with the sinks here as well. You get a bit of a similar kind of information. Typically with a cat operation, you might expect the number of messages to be the same. You can also have a little look at the logs here. So there's a couple of tabs for the different types of logs. So you can see this is the main container within inside this step. And like in an Argo workflow, you have a wait container sidecar. This has a sidecar called sidecar, whose responsibility is for reading and writing messages to and from the topics. You've got events, so you can see when scaling happens. And finally, you can just see the manifest here as well if you want to look at the specification. let's go back to, I'm just going to go back here. I'm just going to go back to the examples. I'm just going to talk a little bit about the examples. This second one is an example of a pipeline with 2 nodes or 2 steps in it. Just going to make sure that's created. Now, if you go back to the list here, you can just see I've just created that. It's the top of the list here. And you can see this has got two steps in it. I said 2 nodes, it should be called 2-step. Step A and step B. This is the one we looked at a little bit earlier. This one reads from a Kafka topic, performs some kind of processing, writes it to a NAT streaming subject, and then writes it to an output topic. And the status on this will just show you, you can see this is currently gray because it's waiting to actually schedule this particular pipeline because my cluster pro doesn't have enough space to do it at the moment. We talked a little bit about things like filter, flatten, expand, and map. I'm just going to dive into filter, which shows you filter operation. This particular pipeline will filter to only include messages that contain the word capybara, which is a type of small rodent, I think, and reads them from a Kafka topic and writes them out a Kafka topic. This expression syntax is the same expression syntax we use quite commonly on Argo workflows now. So that should be familiar to a lot of people. Let's just go back here as well. And then, we talked about flattening, expanding. So flatten down to, dot saturated key values and expanding out of it. Then a map operation. So this one, I'll dive into this one as well. This one's a map operation and basically prepends the string hi to the message that comes through the pipeline. Now, I haven't talked about the format of messages. The lowest common denominator message format is a byte array. So NAT streaming only uses byte array. It doesn't have the ability to add metadata in the way that Kafka does, or even HTTP request. So messages are all currently a byte array. One question we don't know at the moment is if we need to have some kind of internal format for messages to support something, for example, like the cloud events message format or something else that allows us to add additional metadata to each one. So interesting to see what people's thoughts on that. Then we have an auto scaling pipeline, example of the auto scaling here. So the way that scaling works out of the box is you can define a replica ratio, i.e. the number of replicas we should be running for each n pending messages. So for example, if your ratio is 500 because you think you're able to process 500 messages a second, then you might have a ratio of 500. And when the number of pending messages grows to 1,000, you'll be running 2 replicas, 1,500, 3 replicas, 2,000, 4 replicas, and so on, up and into bounds. But you can also, it just implements the standard scaling that's used by HPA. So you can also just use HPA-based scaling if you want to scale it using something more sophisticated, which is typically more complicated to set up because you'll need to install probably metric service and a HPA as well. So that may be more complicated than a lot of people need by default. Okay, so let's have a little look at a Go handler. This is let's look at a Python handler because Go, Java are very similar to Python, but Python's probably more interesting. So this is a Python handler. Basically, you can define the code that you want to run in terms of a handler function and just a runtime. And what that'll do is it'll build and compile that code for you. So this is suitable for very simple use cases where you can probably write the code that you want in 20 or 30 lines and you don't have any significant external dependencies. Every dependency is kind of out of the box. And this is probably familiar to people who've used AWS Lambda as well. It's a similar kind of syntax. Then we have a Git option. These are both intended to address the difficulty of having to build your own image. The Git option actually will check your code out of Git and run it with a particular image. So this one here checks out this particular repository, checks out the subpath example /git on branch main, because branches are called main these days. And then we'll actually run that within inside this particular image. And I think it's usually pretty interesting for us to have a look at what this contains. So let's have a look at the examples repository. Let's go examples, Git. Oh, slow, and I'm not even on the corporate VPN today, so I'll have to wait for it to load. Here we go. So here's an example of a Git. Basically, this allows you to provide something very similar to a Docker file here. And in this example, I'm basically providing an entry point, which is the code to run. I need to provide a handler function, as we mentioned before, and then a main function, which is kind of copy and paste code. I want to just go back to the examples. Where's the examples? It's possible to run a pipeline to completion or not to completion. So there are two ways to run a pipeline. So one that runs to completion would be one where you're just processing a kind of a finite amount of data. And the way that you run to completion is simply by exiting 0 in your container just to indicate you've finished. And in a pipeline that runs to completion, you can actually mark it you can mark steps as a terminator. So when a particular step within your pipeline runs to completion, that the whole pipeline is terminated. So if you've got 3 or 4 steps, you might have the steps passing information between one another, or from the first step through to the last step. And if the last step exits, then the whole pipeline will then be shut down for you automatically. Or you can have them run, if you're processing an infinite, unbounded stream of data, then obviously your pipeline would run ad infinitum. And we talked a little about containers. I'll skip over that as well. Simply, you can specify the container that your pipeline runs. And then I've got a couple more sophisticated examples of a veterinary and a word count one as well. So again, these can be seen in the user interface. So here's the goat one. You can see that's running there, processing a small number of messages at the moment, and you can have a look at some of the more complicated ones. This is an error handling pipeline demonstrating retry policy. So this is actually kind of an interesting example of where the steps aren't connected. Typically, you'd expect to see the steps connected, but I disconnected them in this one, and the top kind of sub pipeline reads from a cron topic, and the handler itself randomly emits an error. So it's running, if random of 2 equals 0, then raise an exception, otherwise just return the value. In the first one, it's retrying, because if you retry randomly, you'll ultimately get success. And that uses a back off policy, a retry back off. And this second one here has a retry policy of never, so never retry. So you can see around half the messages have failed, because it's a coin toss as to whether they're failed, and that's reported in this. And that's kind of useful because it allows you to have a step that's robust to your container being killed by Kubernetes, which can happen at any point. Anybody who's written workflows knows one of the biggest challenges of writing a workflow is getting your retry set up successfully, because of course any particular step within a workflow can randomly fail. It could be killed by Kubernetes because it wants the resources for something else. And Dataflow has that same kind of challenge. So it has the ability to read reliably from a topic and retry if there are any kind of issues with the processor. So for example, if the processor is now unable to connect to a downstream service, then it can just retry. And that means it can give a very high reliability guarantee, not quite 100%, but pretty close to 100%, 1/1000th of percentage. I think the goal is to get it even more reliable than that, because I think we know from speaking to users who want to use this now that it's okay to lose 1 or 2 messages a day, but not any significant percentage of them. And so, losing one message in a million might be tolerable. And we talked a little bit about reliability, and the different sources and syncs have kind of different reliability guarantees, but typically we're aiming for at least once delivery of messages from both Kafka and Stan. It should be at most once for 999,999. Okay, so I went through the examples. If you want to find out more, you can find Argo Dataflow in Argo Project Labs. Kind of really keen to get people's feedback, to think about the use cases, so we can make sure we build out the right kind of features and capabilities for what people need. We've got some idea from speaking to our own customers, but the feedback from the community is really invaluable. Hopefully you'll see that some of the concepts have been borrowed or adapted from both Argo workflows and Argo events. Some of the best concepts around kind of starting and stopping pods and containers and doing things reliably on Kubernetes, which is an interesting challenge in its own right. Okay, does anybody have any questions they would like to ask? feel like I can hear somebody, but it's very quiet. Maybe I'm imagining it.
Maybe did you want to explain like some of the use cases that we're trying to solve by writing this? Or...
Yeah, so we're not looking to kind of replace stream processing tools like Apache Beam. I think and we're not looking to replace tools like Argo Events and Argo Workflows. I think it sits in between those two. And the kind of a very general, use case is processing items of data from some kind of topic or subject. But we're aiming at operational analytics processing. So in our initial case, that would be events, so about application deployments, about requests going through API gateways that need some kind of pre-processing or adaptation or enrichment, those kind of operations before they are put into some kind of AI tool or some kind of data processing tool to extract anomalous events from the list. That would be the initial one, but anything that would actually process streams of events is targeted. Okay, so I will just go back to our menu for today. So I hope you guys enjoyed the demos that we have today. If you want to learn more, we'll include some links in this document so you can go and read the slides yourselves and also be able to kind of ask more questions. You can obviously come and ask questions on the CNCF Slack, which we've now migrated to in the Argo Workflows channel. You can come and ask questions about that. I think there's an Argo Dataflow channel, but there's not much in the way of things going on there. If you are interested in presenting at the community meeting, we always love to see people talking about what they're doing. It's always great to see people's tools that they've built on top of Argo Workflows and Argo Events, but also it's really good to see people's kind of other use cases, what they're doing with it. We will find that really interesting and we appreciate that. Okay, and thank you very much for all joining today. Oh, and the other thing people always ask is this being recorded? Yes, it's been recorded and the video will be available on YouTube later today. Okay, thank you very much.